Okay, students, we have completed our NCERT short notes on the naming reactions of the haloalkanes and haloarenes. Now, in this session, we are going to concentrate on the alcohols and phenols of the next chapter. It is in the second chapter of the organic in the class 12th. Okay, so this is how we are going to make the NCERT into juice. Okay. So now the first topic, naming reaction, write a short note on. This will be, the question will be like this. Okay, here we are going to start with the acid hydrolysis. Okay, so we are in the topic of alcohols and phenols, and especially naming reactions we are going to focus. Okay, so here first topic is acid hydrolysis and acid catalyzed hydrolysis. Okay, so the name hydrolysis or hydration, okay, is addition of the water. Is what? Addition of water. So when you add water, and we are adding the water to the alkene here. So this is the alkene, double bond, and water we are adding. So for better understanding, you have to write water as a H and OH. Okay. So in this H and OH, OH will be negative charge and hydrogen will be positive charge. Hydrogen will be positive charge and OH will be negative charge. Okay. So in this H and OH, the one part will be, OH part will be attached on one carbon and hydrogen H plus will be attached on the second carbon. See, this is what we are going to get. Okay. So earlier, before the reaction, it was alkene. It was alkene. And as a final product, we got the alcohol. Okay. So, but the problem with this is it is a slow reaction. So to initiate the reaction, we have to have a reagent. So that reagent is the acid. So acid will provide the H plus. Now H plus, it is here electrophile. H plus, it is called as a electrophile. That means it can attract the electron. Electrophile means attract the electron. So this is called as electrophile is used, therefore it will be called as a electrophilic addition. It is called as what? Electrophilic addition reaction. Okay, the reaction is initiated by electrophile. That's why it is called as electrophile. Okay, and we are adding with respect to the double bond. That's why it is called as a electrophilic addition reaction. It is called as electrophilic addition reaction. Okay. So in the acid hydrolysis, the one carbon atom, the addition will takes place. On one carbon atom, you will find H plus, and another carbon atom, you will find OH minus. So H plus and OH minus is added, then the double bond will become as a single bond, and alkene will be converted into alcohol. Now the next sentence is about the Markovnikov's rule. Okay. So what is Markovnikov rule that I am writing here? The negative part of adduct. The negative part of adduct. I will give you example. What is adduct? You will understand. Negative part of adduct adds to the carbon atom. Adds to the carbon atom. Adds to the carbon atom. Carbon atom containing. Carbon atom containing less number of hydrogens. Less number of hydrogen, or we can say more alkylated. We can say what? More alkylated. Okay, it can be more alkylated. So now here adduct means this is the adduct. Okay, and this should be unsymmetrical. Unsymmetrical means one part it is adding hydrogen, another part it is adding OH. So H and OH. Okay, this is the negative part. So this is positive, this is negative part. So up to now, I think it is clear. Negative part of adduct adds to the carbon. Now addition must be taking place on the this carbon and this carbon. So this is the negative part. Okay. So I will use the different color for easy understanding. This is the negative part of the adduct. Okay. adds to the carbon atom containing less number of hydrogen. Here we can see only one hydrogen is there. And here we can see how many hydrogens are there, set two hydrogens. So negative part of adduct adds to the carbon atom containing less number of hydrogens. So if OH will go this side and hydrogen will come this side, and this is the product formed. This is what called as a Markovnikov rule. So first naming reactions of alcohol and phenol completely explained the acid hydrolysis. Okay. So by the acid catalyzed hydration, alkenes react with water in presence of acid as a catalyst to form alcohols. In case of the unsymmetrical alkenes, so this also I am going to tell you now. In unsymmetrical means this is the double bonded carbon atom. On the double bond carbon atom, one side it is methyl, another side it is CH2. H2 is there. That's why it is called as a unsymmetrical alkene. So whenever unsymmetrical alkene is there, hydration is done, then OH will attach on the carbon atom with less number of hydrogens. Okay. This is what about the acid hydrolysis, the very first naming reaction. Okay. Now let's go on to the next topic. Okay, this is the mechanism. So what is the mechanism and how it is different, that we are going to study now. Okay, so here mechanism will takes place in the three steps. First of all, protonation of alkene. As I told you in the starting only, it is a acid catalyzed reaction. And what is the purpose of acid? It will provide you with the H plus. Provide you with the H plus. See, this is the H plus provided from the acid. Acid is providing the H plus, and that protonation of alkene from the carbo to form the carbocation by the electrophilic attack of H3O plus. So this is the alkene. This is what alkene, and this is the electrophilic protonated water. Okay. So now on reaction, see here you will find the C positive. So this C positive, wherever it is there, this is called as a carbocation. Okay. Now this is electrophilic attack. So protonation, that means ultimately only this H plus is being added here. Which side? This is the H plus coming from the acid. This is generated from acid. Okay. So in the first step, what we got? Proton from the acid is added to the alkene to form the carbocation. Proton from the alcohol added to the alkene and to form the carbocation. That is the first step. Now, second step is nucleophilic attack. So, as we have used H2O plus H2O, out of that now H plus is only reacted, but we are left with OH minus. So, first reaction is done by the H plus. Next, it is followed by the OH minus. So OH minus will, where it will attack, obviously wherever the positive charge will be there. Okay. So then deprotonation. See here, as I told you, reaction will be initiated only by the acid. Reaction will be initiated only by the acid, but leftover after that it should give back what it has taken. See, H3O positive, it was formed because of the acid. Now it is given back. Okay. So total three steps. Finally, we got alcohol, and finally we are given this back to the acid. So reagent will never be consumed. It will be initiating the reaction, but at the end of the reaction, it will be given back. Okay. So these are the three steps related to the acid hydrolysis. I think it is clear now. Now we will go on to the next part. Hydroboration oxidation, very very important. This is also one of the preparation method only. Okay, so how you will prepare and what is the difference between the previous and this one, we are going to study now. Okay, so hydroboration oxidation, in some books and in exam also they are giving like HBO. Okay, so HBO there is a channel also, but that channel it is not there. Okay, it is HBO means channel name is home box office, but here HBO means hydroboration and oxidation. Okay, so diborane BH3 twice react with alkene to give trialkyl boranes. See, this here 3 moles must be available. In short, see, first mole of alkene is this one and BH3. So one hydrogen will be attached onto the inside carbon and BH2 will be attached to the terminal carbon. So this is what it is prepared now. Okay. Now double bond is converted to single bond. Now there is one more mole. Like that, how many moles? This is the first mole, this is the second mole, and this is the third mole. That's why we have written here trialkyl boranes. So when you add the trialkyl boranes, this alkene will keep on converted into single bond, and the hydrogen of the borane will be attached to the central carbon atom. Okay. Now this is what trialkyl borane. Okay, up to here, addition product. Then this is oxidized to alcohol by using the hydrogen peroxide. In after that, hydrogen peroxide we are adding. So when you add the hydrogen peroxide, the hydrogen peroxide means OH and OH. So one OH will go this side and OH will go this side. Likewise, 3 moles we will use. So 3 moles of B with OH, 3 moles of OH with each CH3. Therefore, it will form the 3 moles of alcohol. Okay. And you should be aware that this is an anti-Markovnikov product because in the previous example, we found that OH was here, but now it is OH on the right side. This is called as an anti-Markovnikov's product. Okay. Anti-Markovnikov's product. So that is what difference between the Markovnikov's and anti-Markovnikov's rule. Okay. So this is about the hydroboration oxidation. Okay. Now that is what I have explained here. The addition of borane to the double bond, addition of the borane to the double bond takes place in such a manner that boron atom gets attached to the sp2 carbon atom carrying greater number of hydrogen. So in the previous example, it was the situation CH2CH. So boron will be attached to the greater number of carbon carrying greater number of hydrogen, and hydrogen atom will be attached to the carbon carrying less number of hydrogen. Therefore, the alcohol so formed looks as if it is been formed by addition of water into the alkene opposite to Markovnikov's rule. That's why it is called as a anti-Markovnikov rule. Okay. Now in this reaction, alcohol obtained is a excellent yield. Okay. So when you want anti-Markovnikov product and high yield, then the best process is HBO reaction. Okay. So this is what about the HBO, hydroboration oxidation. First, trialkyl borane. Second, H2O2, when it is added, it will be converted into alcohol. Okay. Now let's see the third naming reaction. What is the third naming reaction? Esterification reaction. Okay. Esterification reaction, what it is that we are going to study now. Alcohols and phenols. It is applicable to what? Both alcohols and phenol. Our chapter is alcohols and phenols react with carboxylic acid or acid chloride or acid anhydride. So this reactant is common, alcohol or phenol. It can react with carboxylic acid, it can react with acid chloride, it can react with acid anhydride. If you don't know, don't worry, here everything is clearly written. This is the carboxylic acid, okay? And this is the acid chloride, RCOCl is called as a acid chloride, okay? Next, acid anhydride. So this is the acid anhydride. Okay. So these are C. AR means phenol, RO means alcohol. So it can be alcohol or it can be phenol. Alcohol or phenol when treated with alcohol or phenol when treated with carboxylic acid you can treat, or you can treat it with the acid anhydride, or you can treat it with the acid chloride. But ultimate product is our heading. What is the heading? It is a ester. Okay. So ester is in general you can write it as a RCOO R dash also, but for structural easy structure I have written like this. Okay, RO uh, C double bond O R dash. Okay, so that means one oxygen is directly attached to the alkyl group and another alkyl group is attached to the carbon. Okay, so this is what the ester structural formula will be like this: C double bond O and one single bond O. So this is the ester, this is the ester, and this is the ester. In all cases, we are getting a common product of ester, but byproduct is changing. If we are using the carboxylic acid, we are getting a byproduct of water. If we are using the acid anhydride, byproduct is another carboxylic acid. If we are using the acid halide, another byproduct is HCl or HBr. Okay. So this is how the next esterification reaction. Okay. Now let's see the next part. Reaction with hydrogen halides. Okay, so people may think that is it a reaction, naming reaction? Yes, it is called as a Lucas test. What it is called as Lucas test. This can be used as the very important distinguishing test. Very important distinguishing test it is. Okay, so Lucas test is used to distinguish the primary alcohol, secondary alcohol, and tertiary alcohol. Okay, so we are going to study distinguishing also in organic. From the NCERT we are going to cover all naming reactions once. Okay, all naming reactions once, and second thing we are going to do the distinguishing. Okay, like how to distinguish alcohol or phenol or primary alcohol, secondary alcohol, aldehyde, ketone. So these are all board pattern questions and examination pattern question and difficult to understand. Okay, then we are going to cover with the conversions. So like that, if you do it chapter wise, then organic will be highly scoring and easy to understand. Okay, now let's come back to our topic. What is that? Reaction with hydrogen halide is also called as Lucas test. Okay. Alcohol, when treated with hydrogen halides, haloalkane is produced and water will be produced. Okay. So that is called as a Lucas reagent. So Lucas test, and what is Lucas reagent? See, I am circling it. Concentrated HCl and ZnCl2. Concentrated HCl and ZnCl2. Like that, if you mark it out, these short notes are going to help you out a lot before the examination. The time is very less, but thing you will study will be more. And now that time what you will focus only what you have underlined. Okay. So the difference in the reactivity of three classes of alcohol with HCl and distinguishes one from the another Lucas test. So while see alcohols are soluble in the ZnCl2 oblique HCl, but problem comes with the product. Here Rx, that is halides are immiscible, therefore produce turbidity in the solution. So as soon as alcohol converted into haloalkane, turbidity will be generated. So turbidity generation will intimate you that reactants are now converted into product. So if highly reactive, so fast reaction like tertiary alcohols, turbidity produced immediately because tertiary alcohols are highly reactive. So if any reaction you understood that there is a alcohol, but you don't know whether it is a primary, secondary or tertiary, then simply turbidity, if it occurs immediately, that means it is a tertiary alcohol. If turbidity does not produce at room temperature, then it means primary alcohol. If turbidity produced after few minutes, then it will be secondary alcohol. So this way we can differentiate the alcohols into three parts. Okay, what is that? Primary alcohol will not give, but it will give on heating. At room temperature, turbidity will not be produced. Whereas secondary alcohols will produce turbidity after few minutes. And the fastest alcohol is tertiary alcohol. They will produce the turbidity as soon as You add the Lucas reagent to the alcohol. So this way we can distinguish any alcohol. So anyhow, we are going to clearly solve that questions in our distinguishing class. Okay. Now let's move on to the next part. Kolb's reaction, very important, but don't get confused with the Kolb's reaction of the other topic. Okay, the main problem is that Kolb's electrolysis is also there, so that is in no way concerned with the Kolb's electrolysis. Okay, so what is this Kolb's reaction and what is the product? That reaction is somewhat typical, that's why we are going to study in the next slide, but we will have an introduction in this one. Okay, so phenoxide ion, in this phenoxide ion generated by treating the phenol with sodium hydroxide. Okay, so first step, what we will use, phenol we will take, and what we will react it with, sodium hydroxide, and what is the product, phenoxide ion. Okay, even more reactive than the phenol towards the electrophilic aromatic substitution. For the EAS, for electrophilic aromatic substitution, phenoxide is better and highly reactive than the phenol. Hence, it undergoes electrophilic substitution with CO2, a weak electrophile also, and what it will produce, orthohydroxy benzoic acid is formed as the main reaction product. Okay, so what is that orthohydroxy benzoic acid, that we are going to see. Very simple thing you will understand as of now. Phenol plus NaOH. It will give you the phenoxide. Then you will treat it with the CO2. Then you are going to get orthohydroxy benzoic acid. So what is that orthohydroxy benzoic acid? Now let's see. Okay. See, this is a complete reaction with the crystal clear diagrammatic explanation. Okay. So now let's see with the, see, first step, what we have to take? We have to take the phenol. We have to take the phenol. Then it is treated with the NaOH. See, here we are written like this. This is phenoxide. Okay. So I will circle from where to where it is phenoxide. Yes, this is the phenoxide. Okay, so phenoxide, and now it is treated with the CO2. So there is a way of writing the CO2. You will write the CO2 like this. Okay, this is the way you will write CO2. Now this CO2, here it will be negative, here it will be positive. So this negative and positive, there will be converted, it will be attached at the ortho position. At which position? Ortho position. So then this H plus, this oxygen will be plus, carbon will be plus, and here it will be minus. So for clarity, I will write it here only, carbon plus. So C plus is added here on this carbon atom, and H plus. See, in the next step, what we are adding? H plus. So this will become like this. Okay, earlier it was like this. This is a benzene ring. Okay. Now when you add H plus, that H plus will come over here and carboxylic acid will be formed. So this is the 2-hydroxy benzoic acid. The naming also I am explaining here. This is the benzoic acid. This is what? Benzoic acid. And here numbering will start from here. 1, 2. So on the second OH group is there. That's why it is called as a 2-hydroxy benzoic acid. It is called as what? 2-hydroxy benzoic acid, or it is also called as a salicylic acid. Salicylic acid is very important. This is what? Kolb's reaction. Okay. So Kolb's reaction, if you have to write in a short note, Kolb's reaction is conversion of phenol into salicylic acid by using three reagents rather, NaOH, CO2 and H plus. Okay. So already I told you, you have to write a short note on each and everything. In that, 4 things you have to make sure. First thing is, what is the reactant? Second thing is, what is the reagent? Third thing is, what is the product? Okay. So these three things, and with a balanced chemical reaction, then definitely you are going to score a good marks. And at the end of this, what you will make? You will make a tabular form or summary of this all naming reaction, where you will be writing all together in one column names of the reaction. Next, all reactant in one column, all reagent in another column, all products will be in the other column. I am going to show you the format. Okay. Already we have done it in the haloalkanes and haloarenes, but still I will show you when in the last. Okay. And very important topic is Reamer-Tiemann reaction. It is called as Reamer-Tiemann reaction. Okay. So what is Reamer-Tiemann reaction? What is it is used to produce, that we are going to start now. Okay, in the Riemann-Tiemann reaction, here again reactant is common. This in the Kolb's reaction also we are using phenol. In Riemann-Tiemann reaction also we are using phenol. Okay, so on treating the phenol with chloroform in presence of sodium hydroxide, aldehyde group is introduced at ortho position. Okay, so this is a phenol. In any mono substituted benzene, in haloalkane also I told you there are three types of active sites. This is ortho, this is ortho, this is meta, and this is para. Okay, introduced at ortho position of benzene ring. This reaction is known as Reamer-Tiemann reaction. This reaction is known as Reamer-Tiemann reaction. So, for example, if you have to write in short, what is Riemann-Tiemann reaction? Okay. So, the reaction in which aldehyde group is introduced to phenol at the ortho position by treating it with chloroform is called as a Riemann-Tiemann reaction. In the Riemann-Tiemann reaction, what is the reactant? Phenol and chloroform. Okay. And what is the reagent? NaOH, aqueous NaOH. And what is the product? Salicylic aldehyde. Previously in the Kolb's reaction, we have prepared the salicylic acid. In the Riemann-Tiemann reaction, we are going to produce the salicylic aldehyde. What we are going to produce? Salicylic aldehyde. Okay. So, and in this one, in the entrance examination, even in the board examination or simple examination, they also ask what is the intermediate benzyl chloride. Okay, what is intermediate? Benzyl chloride is hydrolyzed in presence of alkali to produce the salicyl aldehyde. Okay, so first of all, I will tell you the mechanism here. Okay. Mm. Okay, here it is hydrogen is there and CHCl3. You will write CHCl3 like this: CHCl2, CH and Cl2, and one chlorine. Okay, uh, saying chlorine, writing hydrogen. Okay, so this chlorine of the chloroform, this is what chloroform it is. CHCl3 is called as a chloroform. Okay, so chloroform is eliminated. Chloroform is eliminated uh, with the chlorine. From the chloroform, what we are going to remove? Chlorine. And from the benzene, what we are going to remove? Hydrogen. So left over with the CHCl2. This I am telling you at the ortho position changes. And here NaOH is there. So in the NaOH, this hydrogen and this Na, sorry, this will be Na. Okay, this is going and replacing. Okay, so this is called as a sodium phenoxide. Up to here only I am telling you, this is called as a sodium phenoxide. Okay, which oxide? Sodium phenoxide. Now, this is what called as a benzyl chloride. Apart from this, this is intermediate. It is called as a benzyl chloride. In this one, what happens? This OH will be substituted. OH of the NaOH will be substituted here and it will be converted to aldehyde. And again we will use the, first we have used the base, then we are going to use the acid, finally we are going to get salicylaldehyde. Okay, so this is the mechanism side. With mechanism and as per the board pattern, as per the entrance pattern, all preparation is done now. Okay, so let's summarize. Riemann-Tiemann reaction used to prepare, yes, salicylic aldehyde by using phenol with chloroform in presence of aqueous and NaOH. Okay, so this is what the summary of the Riemann-Tiemann reaction. Okay, I think it is clear now. Okay, if you have any doubts, you can ask me. Otherwise, we are going to start with the summary table. So this is the summary table. Okay, revise it now. Let's fill up. So here I am showing you the model how to fill up this. Okay. So first of all, we have to write the name of reaction. In this session, we have studied the first naming reaction as acid hydrolysis. Okay. What we have studied? Acid hydrolysis. Okay. And what was the reactant? It was the alkene. Okay. Alkene and water. Okay, alkene plus water. And what was the reagent? Acid. Okay, acid. In the acid we are going to use only H plus. And what is the product? Product is alcohol. Okay, and if anything special note you wanted to write, you can write it. What is the special note? It product will be Markovnikov product. Okay, what is the product? Markovnikov products. So like this, if you write, all things will be together. This is about the first reaction, acid hydrolysis. Like that in every chapter, if you make at the end of the chapter and end of the naming reaction, that is going to help you a lot, help you out a lot. Okay. So let's see with the next naming reaction. Let's see with the next naming reaction. Okay, next naming reaction, what we have done? Channel name, yes, hydroboration oxidation. Okay, hydroboration oxidation. Hydroboration oxidation. What was the reactant there? Same alkene. Okay, but this water is replaced now with the BH3. Okay, and at the end of the reaction. Okay, so better to write it here only. In the first step, we will use the BH3 first reagent. Okay, or BH3 we can say twice, and second we will oxidize with the hydrogen peroxide. Okay, here also it is going to be a product alcohol, and but what is the difference between the above product and below product? Yes, it is going to be the anti-Markovnikov rule. Okay, sorry, anti-Markovnikov rule, Markovnikov's. Okay, anti-Markovnikov's rule or anti-Markovnikov's product. Okay, this I have written wrong, anti-Markovnikov's. Okay, product, like this second reaction. So I hope all reactions you can make it now. Okay, so if you do it on your own, that will be the best notes. While writing itself, you are practicing, you are understanding, you are memorizing. Okay, so all things will be together. This I think you can make it now with the two models explained by me. Okay, so third row is esterification. In the esterification, third naming reaction. It is alcohol and phenol when treated with carboxylic acid or acid anhydride or acid halide. Then esters are formed. Okay. Now next naming reaction. We are left with some more naming reaction. Let's finish it fast. Okay. Next reaction is Kolb's reaction. Sorry. Kolb. Before that we have one more reaction. Test. That is test. Okay, what is the test called as? Lucas test or Lucas reaction. Okay, Lucas reaction. So in the Lucas reaction, we are going to have alcohol, okay? And the reagent is HCl oblique ZnCl2. And product will be haloalkane. What is the product? Product is a haloalkane, and if it is 3 degree, immediate turbidity. 3 degree if it is there, immediate turbidity. Immediate turbidity. 2 degree 5 minutes. It will take at the 5 minutes. Okay. 1 degree no turbidity at the room temperature. Okay. Then Coles reaction. Then comes with the Coles reaction. In the Coles reaction, we are going to use the phenol. We are going to use the phenol. Then reagent will be CHCl3 with NaOH, aqueous NaOH. Okay. And the naming reaction, it is a very important commercial name product. What is that commercial name product? Yes, salicylaldehyde. Okay, salicylaldehyde. Okay, salicylaldehyde is the product. And after that, Reamer-Tiemann reaction. Okay, Reamer-Tiemann reaction. Reamer-Tiemann reaction. Here also we are using phenol only. Okay, so but sorry, here it is CO2 and salicylic acid. Okay, in the Coles reaction, we are going to use the CO2. Okay, in the first step, we are going to use the CO2. Second step, we are going to add acid hydrolysis. Okay, then salicylic acid. Okay, salicylic acid is the product. Understood? Coles reaction. In the Reamer-Tiemann reaction, phenol only, but here we will use the chloroform CHCl3, and second step we are going to use the NaOH, then we are going to get the salicylic aldehyde. Salicylaldehyde. Okay. So this is the summary of the today's naming reaction of alcohols and phenols.